Good evening. So today's video is about the software architecture. So in this video, we'll see about the software architecture, software design, important need of software architecture, 4+1 view model, activities in software architecture, and fundamental design issues. So first, we will start with software architecture. So what is software architecture? So the software architecture of a program or computing system is the structure or a structure of the system which comprises software elements and the externally visible properties of those elements and the relationship among them. So also software architecture we can define it refers to the high level structure and organization of a software system. It also describes the system's fundamental design principle, the relationship between its components and how they interact to meet the requirement of the project. Software architecture serves as a blueprint of the system and act as a guide for development, implementation, and maintenance. So, software architecture it is an abstract view that distills away implementation details to concentrate on the behavior and interaction of black box element. While architecture is the form of design, it especially serves as a first step toward achieving desired properties and act as a tool for communications and reasoning. Next, software architectures. The architects input like three types of requirement. Okay, first one is functional requirement, quality attributes requirement, and constraint. So, what is functional requirement? Like which satisfy by assigning responsibility to architectural elements. Second one is the quality attributes requirement, like how fast, how resilient. These are the satisfied by design of architectural structure. Third one is the constraint, like design decision with zero degree of freedom must use a specific language or module. These are accepted or reconciled. So next one is software architecture versus software design. So all architecture is a design, but not all design is a architecture. So this diagram we can see. So inner part is coding, design, and architecture. So next one is the software architecture versus software design. So for architecture is related to non-functional requirement, and for design it's related to functional requirement. So also software architecture have three key aspects. One is structure, component, and interaction. So what is structure means like define how the software system is divided into component, subsystems or layer. Like example, client server, microservices, monolithic architecture. Component like individual parts of the system that perform specific function. For example, like database, user interface, APIs, interaction like describe how the component communicating and coordinating with each other, including data flow, protocol, messaging. So this comes under interaction. So next one is the software design. What is the principle behind the software design? Like uh, it focuses on maintainability, scalability, performance, security, and usability. And another way we can define also the detailed planning of individual component module and their internal logic, focusing on how to implement specific parts of the architecture. That one is the next topic is importance and need of software architecture. So, what are the needs of software architecture? So, architecture is critical because it inhabits or enables quality attributes such as performance and security. Already we talked about the performance and security. So, the main uh, focus for design principle is maintainability, scalability, performance, security, and usability. It enhances the communication among stakeholder by providing a common language, enable reasoning about managing change, about the system's life cycle, It also provides a basis for cost, schedule, estimate, and allow for the evolutionary prototyping, permits the incorporate of independently developed components and the reuse of models, and also the need of software architecture for manage complexity, ensure the quality attributes like non-functional requirement like directly influences performance, scalability, security, maintainability, and reliability, and ensuring the system meet business need. It also facilitates communication, act as a common language for developer, stakeholder, and manager, aligning everyone on the system structure and rules. And it also need for software architecture for guides development, like serves as a blueprint for the development team. Next one is it's also enables evolution and maintenance, support decision making, reduces costs and time. So let's see evolution and maintenance. Like a good architecture makes system flexible and adaptable to changing requirements, enable technology and future growth with minimal rigor. It also support decision making, like allow for early analysis of the system qualities. It also reduces the cost and time. Next topic is the 4 plus 1 view model. 4 plus 1 view model is developed by Philip Witchin, the creator of 4 plus 1 view model, and the primarily categorized architectural documentation in these sets of the views. So the first one is the logical view, development view, physical view, and process view. So and one is the scenario. These are the parts of the 4 plus 1 view. 4 plus 1 is a view model used for describing the architecture of the software intensive system based on the use of multiple concurrent views. So, what are the different stakeholders available in 4 plus 1 view model? Like we are considering end users, developers, system engineer, project manager, and the four views of the models are logical view, development view, process view, and physical view. So let's talk about the first view. First one is the logical view, concerned with the functionality that the system provides to the end user. So we can consider the UML diagrams are used to represent the logical view that include class diagram and state diagram. Second one is the process view. The process view is the second view of 4 plus 1 view model, which deals with the dynamic aspect of the system, explain the system process, how they communicate, and focuses on the runtime behavior of the system. So for this, we can consider the UML diagram for sequence diagram, communication diagram, and activity diagram. Next one is the development view, which illustrates the system from a programmer's perspective, and also it is concerned with the software management. For this UML diagram, we can consider as package diagram and component diagram. Next one is the physical view, which depicts the system from a system engineer's point of view. It also concerned with the topology of software component on the physical layer as well as the physical connection. These components, UML diagram used to represent the physical view include the deployment diagram, scenarios. Next one is the scenarios. The description of architecture is illustrated using a small set of use cases or scenarios which become fifth view. And the scenarios describe the sequence of interaction between objects and between processes. It also serves as the starting point of test of your architecture prototype. This view is also known as use case. So this is the diagram for 4 plus 1 view model architecture. So here start with logical view, implementation view, process view, and deployment view. You can see in the diagram. And next topic is activities in software architecture. So these are the several key activities. First one is the gathering architecturally significant requirement, which is includes stakeholder and business goal. Next one is designing, which is used a method like attribute-driven design (ATD) to make structural decision, documenting, recording, view, and notation to communicate the design, evaluating like architecture trade-off analysis method that is called ATM to identify risk, ensuring conformance. And next topic is the fundamental design issue. So the sources identify seven categories of architecture design decision. First one is the allocation of responsibilities, coordination model, data model, managing the of resources, mapping among architecture elements, binding time decision, choice of technology. So these are the fundamental design issues. Remaining topic we'll see on next video. Thank you.